This video discusses some topics for graphics in Octave, and this is far from all the graphics functions and capabilities that Octave has, but it serves as an introduction to some of them, and we'll use these functions in our planar manipulator program. We will use these graphics functions to animate the planar manipulator. Before starting with the graphics, let me go over a couple of items of interest on matrices that we will use, that you can use for the animation project. So first of all, concatenating a matrix. Concatenation means adding something to the end. So here we declare a matrix A and assign the values 3, 5, and 8 to that array. And then if we want to add a 17, a new element to the end of the array, we can just write it as such in this new command. So we have a new matrix A and then the element 17 concatenated to the end. And so then the result is just the original matrix with a 17 tacked on the end. And you can do it with matrices of, more than one row. So here's an example where we have a 2 by 3 matrix, and say we want to stick on this extra column. Then we can just say that matrix D is a concatenation of B and C like this. And so then here will be the result. Concatenation is useful, especially in loops, if you want to keep adding data to the end of a matrix. In other languages, you'd have to declare the size of the array first, and so you wouldn't be concatenating. But in matrix, MATLAB, but in Octave, you can concatenate arrays. Function use are two useful functions for matrices, or the max and min function, and they will tell you the largest and smallest values in the array. So here's an example where we have this array M, and it's got 5 elements in it, and then the max function of M returns the largest value, and min function returns the smallest value. And you can also use the abs function to get the absolute value, and this works on matrices, or scalars. A scalar is really just a 1 by 1 matrix in Octave. But the abs function on that matrix M would return the matrix with all positive values. And then we can use the max function of that to get the largest value in an absolute sense in the original matrix. So the value that's farthest from 0 in the matrix M is at -128. And so we can use the abs function combined with the max function to determine what the value is that's largest in the absolute sense. And now on to the graphics. There are graphics objects in Octave, and each one has a function with the same name. And what that function does is creates the object and returns a handle, a graphics handle, which is a pointer to that object. Here's a list of the different types of graphics objects in Octave, and we're going to use 3 of them in this animation project. So specifically, we'll use the axes, line, and patch objects. So the axis function, it creates an axes object, and it's also used if the if the axis has already been created, you can set the limit and appearance of it. So here's a form for creating an axes object. You call the axis function, and then provide an array giving the min and max x coordinates, min and max y coordinates, and you can even provide z coordinates too if you want it to be in 3D. So like I said, these functions create the object and then return a handle. And then there are options. Whenever you're using this function, you can set the ratio, the aspect ratio, the limits, and then tick marks and labels for the axes. So here's an example. If we enter this command, axis, and then the x low, x high, y low, y high, and then this option, which is equal, which makes the x distance equal to the y distance, then we would get this right here. I know it's kind of hard to see, but we have here an image or a figure technically, and it has this axes object. The x range is from -50 to 50, and the y range is from 0 to 100. And you see that the scaling on x and y is equal. So, as I said, now we have this figure object. And a rectangle, the rectangle function creates a patch object. And so the patch is the graphics object, and then this rectangle function just simplifies the creation of a patch object with some specific characteristics. So, for example, the position, the curvature, the edge color, and the face color are things that you can supply through rectangle to the patch function. Position is the location of the lower left-hand corner. So position is a 4x1 array. The first two elements are the xy coordinates of the lower left-hand corner, and then the third and fourth elements are the width and the height of the rectangle. Curvature is a value that ranges from 0 to 1, and 0 corresponds to no curvature, that is square corners on the rectangle, and 1 results in a circle. So you have a range from 0 to 1. And then edge color and face color are vectors describing the red, green, blue color values. Here's an example. First of all, go ahead and set the axes to -1, 5, 0, and 5, and then call the rectangle function. And so we first say which property we're specifying, and then we give the value for it. So here's the position property, and it has 0, 0, so the lower left-hand corner of the rectangle is going to be at the origin. It's going to be 3 units wide and 4 units high. The curvature of this rectangle will be 0.7, so it will be rounded. And then the face color is going to be blue, so red, green, blue. And here's the result. So here's the axes set by the axis function, and then here's the rectangle that we get. And you can see the result of the 0.7 curvature. The width is 3, height is 4, and then the position is at 0, 0 for the lower left-hand corner. So that would be more clear if the curvature was set to 0. And then we have a blue rectangle, and then there's no edge color specified. The line function is a common function. Really, the plot function is a common way of generating plots, but the line function is a lower level function that's used by plot. So line is used to create a line object from x and y values and possibly z, and then insert the line object in the current axes. So here's an example script. We declare an array x, values ranging from 0 to pi, 20 values ranging from 0 to pi, and y is the sign of all those values, so y is a 20 element array. And then we set the axes and then create the line object, and here's what we get. So here are the axes set by the axis function, and then line creates this line object. And so the arguments to line are two arrays. We have an x array and a y array. And so the first element of x will be plotted with the first element of y, so we have 0, 0. And then the second element of x will be plotted with the second element of y, and so on. And that will create the line. You could also use this to create a line, line segments, like for the robot manipulator. You can have if X were 1 by 2 matrix and Y was a 1 by 2 matrix, then we would just have a single line segment from x1, y1 to x2, y2. So as I said, the line function is a low level function compared to the plot function. And then two other functions relating to this project. First of all, the CLF function is used to clear a figure, and what that does is deletes all the objects in the current figure. So objects include axes, rectangles, lines, etc. And then the other is the sleep function. So this is used to suspend the execution of the program or script for the given number of seconds. Here's an example of using sleep. It's a little script that's just 6 lines long or 7 lines long. So we're just going to print this to the screen, lift off in, and then we start this for loop. So the counter in the for loop will be this matrix I, which starts with 3 and goes down to -1 all the way to 1. So it's a 3-element array. 3, 2, and 1 are the elements. And then we're going to print the number I, and then call this function fflush to standard out. And what that does is there's an aspect of Octave such that if this line wasn't there, or if that command wasn't there, then the entire script would execute, and then all the fprints would get displayed to the screen. So this gets the fprints to display before the script finishes running. So then we'll call the sleep function for 1 second, and then repeat the loop. So what does this script do? That's up for you to figure out.